This is question 14 from the first CSAT sample paper. Here we're given a square, we're told the side lengths are b, and we're asked to cut it with one cut that's the diagonal and then two other cuts, so the cuts all meet somewhere in the square. I've drawn it so it's symmetric, it doesn't necessarily have to be. And we're asked where do we have to cut it in terms of b, so what distance from the nearest corner do these other cuts have to meet? So it's making it sound like preferably it's symmetric, so the answers are all the same. We'll have to check we can do it symmetric, but we'll think about that later. So if it looks like this, then we're basically asking what x is. What's this distance from the end of the cut to the nearest corner if all of these 6 areas between the cuts are equal? So if you want to have a go at this question yourself, pause the video now. Okay, so first things first, why can I cut it like this so it's symmetric? Just to simplify the problem for us. The reason is basically if I imagine I do cut it like this, so I've got these 2 symmetric lines, and then I just imagine, say, increasing this angle between them. If that angle starts very small, then obviously this angle in the middle is going to be much smaller than these 2 angles. So this area is going to be much smaller than these 2 areas, which are the same. As I increase it, these 2 are going to, as I increase this angle, these 2 areas are going to decrease and this one's going to increase. So at some point they're going to be equal, and that's when I stop increasing this angle. So as long as I choose this angle right, I can make these 6 areas all equal. So how am I going to find out what x is? Well, to do that I should probably put some more information into this picture. So it's a square, so we know all the sides are length b, we know the length of this diagonal, we know all the angles, so these 2 are right angles and these either side of the diagonal are 45 degrees. And what areas am I going to look at? I'm mostly going to look at these shapes here because those are triangles and it's easier to find the area of a triangle. So let's go and redraw this with all that information included. Okay, so here's my square. I've got the diagonal. What's the length of the diagonal? It's b times root 2. And I've cut this into half, so each of these parts is b over root 2 because it's half of b root 2. And that's good because it gives me a length in this triangle here. And I know this angle is 45 degrees. And if this is x, I also know the length of these edges, which is b minus x. So there's a lot of stuff I don't know. I don't know the lengths of these red lines. I don't know these angles here, or this angle. But actually, I've got enough information to write down the area of this triangle here. So we might think, well, it's not going to be enough because I need to know the area of this as well and set it equal to that. And the main thing to remember is if all these 6 areas are equal and each of them is equal to 1/6 of the total area of the square. So we basically want, if I call this A1 and this A2, we want the 2 areas to be equal and to be equal to b squared over 6 because the area of the square is b squared. And I can write down a formula for the area of this triangle because I've got 2 sides and the angle between them. So it's a half times this, which is b over root 2, times this, which is b minus x, times sine of the angle between, which is sine of 45. And now I've got this formula, I can just set that equal to b squared over 6. And I'll have an equation in x and b, so I can solve for x. So I don't actually need to work out the area of this more complicated shape here. Okay, so let's try and simplify this expression first. Sine of 45 degrees is 1 over root 2, so that means I'm going to combine the root 2's and I'm going to get a 2 on the bottom there. So we've got a half. I'll take out the 1 over root 2 from here, and this is 1 over root 2, so I can simplify them. Then I've got the b from here, then I've got b minus x. So this is just going to come to 1/4 times b minus x. We're setting that equal to this. So we're getting b squared over 6 equals 1/4 of b times b minus x. And what can we do to simplify this? We'll eventually want to rearrange to get x, but first we can divide both sides by b. And also we can get rid of the fractions. So if we just divide both sides by b, we get b over 6 equals b minus x over 4. And now I'm multiplying across, basically by 12, because that's the lowest common multiple of 6 and 4. So multiply by 12 on this side to get 2b, on this side to get 3 times the top, which is 3b minus 3x. Then I just move the x across, move the 2b across, so I'm going to get 3x equals b, or x equals b over 3. So this is my distance x. Since the question was in the form where on the sides of the square with respect to the nearest corner should the other two lines cut, we might just write a sentence saying exactly what x means, although it is clear from our picture. So we'll just say we cut as indicated, so I'm in the picture, with x equals b over 3. And that's the end of this question.